Hello, 7th grade. This week we're going to take a little bit of a detour and we're going to go back and revisit expressions. We worked on this at the end of second trimester and we had some difficulties, so we're going to take another look. All right, so if you remember, there are two kinds of expressions. There are numerical expressions and there are algebraic expressions. So a numerical expression contains numerals. Numerals are another word for numbers. So when you have an expression, you don't have an equal sign, right? It is just sort of like a phrase, not a complete sentence. So all of these are examples of numerical expressions because they involve numbers and they involve some kind of operation. So addition here, multiplication here, division, and subtraction. And they only are using numbers in those expressions, no variables. So a variable, if you recall, is a letter that stands for a number. It's an unknown. It's something that we don't have a value for yet. We'll get to a point where we find that value, but in the meantime, it's just representing a number. And when we write letters, we use lowercase. So you could use a lowercase m, a lowercase y, a lowercase a, okay? Now, because we are using variables, when we use x, it's going to represent a variable, no longer a multiplication symbol. So we're going to have to find another way to write multiplication. All right, so then a variable expression requires at least one variable. So we also call these algebraic expressions. So now we would have x being the variable plus 3. That would be an example of a variable expression. It contains a variable, it contains an operation, in this case addition, and it contains a number, the 3. Okay, so addition and subtraction are pretty simple to write. Okay, multiplication though, because we're no longer using x to represent a multiplication symbol, we need to find another way. So when you have a number times a variable, we are always going to put the number first. Okay, 4x means whatever x is, we have 4 of them. So if x happened to be 2, then 4 of them would be equivalent to 8. Okay, this number that's being multiplied times the variable is called the coefficient. So x is the variable, 4 is the coefficient. Okay, now division, we are going to, as a general rule, no longer use that division symbol that we've used in the past. I don't know if you can see that. In today's examples, I think you might see that, but as a rule, our preference is going to be to write, if we had x divided by 2, we would write it in fraction form as x divided by 2. Okay, so those are the correct ways to write variable expressions or algebraic expressions. Okay, so let's take a look. 5 minus 5. That is clearly a numerical expression or a numeric expression because it only contains numbers. This is 8 divided by x. That would be considered a variable expression. C minus 5, a variable expression. Now here's a terrible example, 100 times 6. Now, how else could you write that if you didn't want to use x as a multiplication symbol? Well, there's a couple ways. You could put one of the factors in parentheses. You could also use a dot like that. Really, the preference is going to be to write it that way. Okay, and then this last one actually contains 2 numbers, which is fine, but as long as it's got that variable, it's going to have to go over here in the variable expression column. All right, so let's take a look. Now we want to take some words and create the expression from the words. So we have to look for those clues that tell us which operation that we are talking about. So 9 more than a number y. So clearly 9 is a number, and the number y is the unknown. So more than means you're adding on, right? So in that case, it's an addition expression. So we could either write 9 plus y or y plus 9. It doesn't matter because of the commutative property. On the second one, 4 less than a number n, 4 being the number, n being the variable or the unknown, and less than means that we are subtracting. So here the order does matter, right? Because n minus 4 and 4 minus n are not going to give you the same result. 4 is less than n. That means you're starting with n and then subtracting 4. So a number z times 3, that's clearly going to be a multiplication problem. Now, they show different ways to write that. We're only going to use one, and that's the center one. 3z is the correct way to write that. Okay, a number a divided by 12, clearly that's a division problem, but again, we are going to write it that way. Do not use that division symbol. Okay, and then 5 times the quantity 4 plus a number c. The quantity of means that that's a group. So the quantity of 4 plus c would be in parentheses, and then we're doing that 5 times. So again, they're going to use, they show you this dot for multiplication, but I prefer that you write it this way. So the way this is read is 5 times the quantity of 4 plus c, exactly the way that the words show under the word phrase. Okay, so now say we had bagels that cost 50 cents each, and we're asked to write a variable expression for the cost of B bagels. Well, you might wonder yourself, what do they mean by B bagels? Well, B is a variable, which means it's an unknown. So we don't know how many bagels are being bought. All we know is that they cost 50 cents each. So regardless of how much you buy, they're going to be 50 cents each, right? So we would multiply 50 cents times the number of bagels, and that would tell you your cost. So that would be the variable expression that represents that situation. Okay, so let's try a couple of these. 6 more than m would be m plus 16, or 16 plus m. The product of c and 3, the product means multiplication. C and 3, we always put the numeric value before the variable. Because if you think about it, what you have to know what c is to know what 3 c's are, right? B times 3, again, 3 goes first, that's the coefficient, and then times the variable. N divided by 3, just like it sounds. X less than 2, the order matters, right? 2 comes first because x is less than 2. So we start with 2 and then we subtract x. 6 divided by z, just like it sounds. 2 less than p, think about the order, p minus 2. 4 fewer than j. Fewer is another way of saying less than. So again, the order does matter, j minus 4. 3 divided by n, just like it sounds. And 8 less than z, z minus 8. Okay? So today you're going to do an assignment called a variable maze. In this variable, you're going to find your way from the start to the finish. And you're going to, I'm going to stop once. So you're going to start where it says start, and you need to finish where it says finish. But the way that you get there will depend on whether you take the A route or the B route. And so when you look at problems number 1, it says the product of M and N. You need to decide whether A or M is correct in how it represents that word phrase as an algebraic expression. And so if in that case, A is correct, right? Mn would be the product of M and N, because that's like M times N. So you start here, and then you would go A, and you would take the A maze until you get to problem 2, and then you have to decide which way to go, either the A way or the B way, depending on which expression is correct. Okay, and then when you're done, you'll end up at the finish, and hopefully the route you took will have been the correct one. All right, give it a try. I'll see you later.